Here is side 1 of our maths memory card on this video of y equals mx plus c, or linear or straight line graphs. So let's go through these different sections over here, and let's go through each one in turn. So calculate the gradient. We're going to learn how to calculate the gradient of a straight line given 2 coordinates. We're going to give you a formula as well for this. And number 2, how to calculate the midpoint of a straight line. The formula as well will be shown to you. How to draw, identify y equals mx plus c, but to draw it from this format over here when y is not explicit. So x plus y equals an integer, and how to look for parallel lines. This topic is called y equals mx plus c. It's the basics of this whole topic. This is a week 9 topic. It's a bronze topic 2. It's a foundation and high level. It's mainly grade 5 over here. Here's an example. Leave this for your best questions in this video, and hopefully steps 1, 2, and 3 will be quite apparent as we go through this. Let's turn over to our toolkit, please. So on your other side of your revision card, you should have 4 clear sections, A, B, and C, D, to jot down your favorite different methodologies during this video over here. So make sure you have these 4 things, pause this, and then let's kick off with our back to basic questions. Question 1, back to basics. Press pause, write this question down. If you have a pre-printed sheet with a graph paper, print this out to save time, and press play when you're ready. So this topic, this question is all about this equation y equals mx plus c. So you'll be an expert at the end of this question, hopefully. So y equals mx plus c is associated with linear or straight line graphs. So let's get down to this question over here. Plot the following graphs without a table. So the key word is without a table. How can we do this really quickly? Now it's used with a method called quick sketch method. And how do we go about this? Well, first of all, let's define y equals mx plus c as such. So we have something called the y-intercept, okay, which is the first thing you should look for, which is the plus c. That means where it intercepts the y-axis over here, the vertical line. And also we have something called the gradient, which is m. M is how steep a line is. How can we identify this, first of all, in this particular equation over here? So we have y equals 2x minus 1. So minus 1 is our y-intercept. That has not got any x associated with that. So we'll put a little box there, minus 1. And your gradient is the number next to the x, which is going to be just 2. Okay, not 2x, but just 2. So let's go ahead and plot this over here. So this is a linear graph, and this is how we've identified m and c, y-intercept and the gradient. So first of all, let's look at the y-intercept. So it's going to be minus 1 over here. So minus 1 is over here. We'll put a little dot for that coordinate. And that denotes your y-intercept over there. That's really easy. It's the first thing we look at. The gradient is now going to be 2. So what we do, we always go 1 across from here, 1 across over here, and we go 2 up, 1, 2. We do that again, 1 across, up 2. We go up 2 because obviously the yellow highlighted bit shows it's 2 over here. We draw a line between all 3 dots. Always do 3 dots, by the way, in case you make a mistake. It has to be a straight line. So this will look like this, just really approximately like that. You can go even further if you want to. We've done it to make it look the simplest way. Gradient of 2, let me explain this one more time. That means what we did, we went 1 across over here, we went 1 across on here, and we went 2 up like that. 1 across, 2 up, and again we went 1 across here and 2 up again over here. 1 across, 2 up. We'll explain what this means throughout the video. This is called a stepping stone, we call it. Stepping stone is simply how you define the gradient, but we'll leave it for that in terms of explaining it in that basic context. Okay, that's the yellow bit over there. Right, let's get down to the second question. Y equals minus 3x plus 4. So the first thing is the y-intercept, the quick sketch method, plus 4. Plus 4 is the y-intercept, which is over here. Gradient is minus 3. So again, we go now on minus 3 over here. We look at the m, gradient. Every one we go across to the right. Across to the right, we're going across 1. We go down 3. 1, 2, 3. It's this dot over here. By the way, it's that dot, that dot. 1 across again, 1 across, 3 down. 1, 2, 3. We simply join up the lines over here. Let's do it. Let's do it again on the black line here. These 3 coordinates, again, you should be able to do it properly even longer, but that's quite approximate for now. to make sure you understand the gist of this. This is how you plot that graph of y equals minus 3x plus 4. Question 2, back to basics. Press pause, write this question down, try to find the equation from this graph, and press play when you are ready. So in this question we're looking at going backwards rather, and we've got a graph in fact, and we're trying to find the equation from this graph, okay? And the equation has got to be in the form of y equals mx plus c. This is a more popular question, okay? We're kind of like working backwards. So first of all, find the equation of the straight line L1 and give your answer in terms of y equals mx plus c. And this is definitely a straight line graph, and we can see that from this line over here. So the quick sketch method says look at the y-intercept first, which is plus c, and then look at the gradient second over here. Let's apply that. So what is the y-intercept? Where does it cross the y-intercept over here? It crosses over this coordinate 0, 3, which is over here. Now the gradient is m. Now to find the gradient, we need 2 points, okay? We need 2 points to find the gradient. We need to make that explicit, okay? So 1 point we're going to put over here, because that was from our original part of the working out. And the second point we're going to put over here, let's say over there. It doesn't matter where these 2 points are, as long as they cross over, let's say whole numbers, it'll make it much easier to find out. Okay, so let's go 1 across. We go 1 across over here, and how many are we going up over here to this point? It's going to be 2. So 1 across, 2 up. We can do that again. That ratio will always be the same for any 2 points. If we pick these 2 points, this one and this one this time, 1 across, 2 up. Okay, so when you pick your 2 points, try to find the y-intercept as one of your points, and obviously try to get 2 whole numbers where they cross over. 2 whole numbers meaning on the x and the y axes to make it easier, but the ratio will be the same wherever you pick the 2 points from this. So the gradient is defined as this. The gradient is defined as the change in y over the change in x. So if we look at it like this, y over x. Now I'm putting a delta sign. Delta just means the change in y over the change in x. Don't worry what that means for now. All you need to know for the GCSE is this: the change in y given 2 points is going to be the vertical line, which is 2. The change in x given 2 points, these 2 points over here, is 1. 2 divided by 1 is simply 2. So that's how easy this is, picking 2 points and finding your gradient as 2. So the final answer will simply be y equals 2x plus 3. Simple as that. Question 3, back to basics. Press pause, write this question down, find the gradient between these 2 points. Press play when you're ready. So this question is quite a common question. It says a straight line L1 passes through the coordinates a minus 1, 1 and b 2, 7. Find the gradient. Okay, so this keyword, the gradient of L1. Now there's a formula for this you need to memorize for the exam. Let's just spell this out first of all very clearly. So a equals minus 1, 1 and b equals 2, 7. There we go. Now we have to label this correctly. Each one is x1 comma y1 in this case, and this one is x2 comma y2. Okay, don't get confused with the x's and y's. 1 means that this is this set of coordinates, and 2 the second set of coordinates, i.e. b over here. So let's see if we can now plug these into our gradient formula. Now m is defined as y2 take away y1, and the whole thing is over x2 take away x1. This is fundamental to your understanding of this topic. It's the change in y over the change in x. Let's simply plug these in. Okay, so we've got y2, which is 7, y1, which is 1. The whole thing now over the change in x. So x2 in this case is going to be 2 minus 1. Look how we're doing the minus 1 here. Okay, if you understand this, 7 take away 1 obviously is 6 over 2 minuses make a plus 3. Answer is 2. M is 2, or the gradient is 2, that's your final answer for this. And that's the way in the exam you should answer this kind of question over here. Now, graphical response, so this is not the way you should answer it, but this is a way of actually understanding it more like, a way that we like to do over here. So A is minus 1, 1. So roughly a sketch of this, minus 1, 1 would be over here. This would be A minus 1, 1. And B roughly 2, 7. So B 2, 7 would be over here. Let's join these 2 points up together, these 2 coordinates. And let's just explain how we could understand this in a better way. How many are we getting across, first of all? Minus 1 is your x coordinate. Minus 1 all the way up to 2 over here. We're getting across 3. 1, 2, 3. This is really, really rough, by the way. 3 across. And on the y coordinate from 1 to 7, we're going up 6. 1, 2, 3, 4, 5, 6. 6 over here. Change in y is 6 over the change in x. 3, we get 2 as well. So 2 is your answer to confirm it on both sides. But the left response is much more better in the actual exam. This is the first toolkit, section A on the gradient. So to find the gradient, we need to have 2 clear coordinates. We're going to call these 2 coordinates x1, y1, x2, y2. We've shown how the gradient is defined as the change in y over the change in x, and more formally how we can write this as y2 take away y1 over x2 take away x1. So just pause the slide, write it down, and this is going to hold you in good stead in the future questions to come. Question 4, back to basics. Press pause, write the midpoints down of these 2 coordinates. Press play when you are ready. So in this question, we're finding the midpoints of 2 given coordinates. We have A, 3, 4, and B, 6, 2. So first of all, let's do the more, let's do the algebra way, which they want in the exam. A equals 3, 4. Okay, let's define this as clearly x1, y1. And we'll do B as well as 6, 2. Let's define this as x2. y2, so the first set of coordinates with a 1, the second set of coordinates with a 2. Now the midpoints is defined by this formula over here, x1 plus x2 all over 2, comma a y1 plus y2 all over 2. Simply plug these in, it's quite simple. So x1 over here is 3 plus 6 all over 2, comma y1 is 4 plus 2 all over 2. This is a one go. 3 plus 6 is 9. 9 divided by 2 is 4.5. 4 plus 2 is 6. 6 divided by 2 is 3. So those are your midpoints over here. So very, very simple to do that. Let's just show this visually as well. We always like doing this to give you a bigger picture. We don't recommend doing this in the exam, but just for you to see this now. 3, 4, a really rough sketch. A 3, 4, B 6, 2, 6, 2 over here. Let's join this up together and let's roughly see if our answer is correct. But remember, they want working out in the exam, which is why we showed method 1, algebra. Let's see if this is good. So 4.5, 3, 4.5 between 3 and 6, and 3 over here between 2 and 4, bang in the middle. We'll call that M, and that's your answer. But look at obviously part A to do your question in the exam. This is section B on your toolkit, so pause this slide on your revision card. In section B, write down this formula for the midpoint. You could see it visually, or you could see it in this algebraic notation over here. In any case, pause this, write it down. This will hold you in good stead in the future. Question 5, back to basics. Press pause, sketch this graph, and press play when you're ready. So you should definitely understand now how to plot y equals mx plus c. Now to plot this graph over here, it looks a bit different from the one before. Why is that? Because simply we have, let's say, x and y on the left hand side. Okay, so we need to rearrange this to make y by itself. Okay, because we need to plot a graph always in this form, y equals mx plus c, where we clearly can define the gradient and the y-intercept. So we have x plus y equals 3. The first thing we're going to do, well, let's put these little boxes underneath each one of these, separate the x's, y's and numbers. We're going to get this y on the left hand side, this plus x, we're going to shift over to the right hand side. So y equals 3 minus x. Okay, look how we did that. Simply took the plus x, shift this over to the right hand side over here. We like to write it like this: y equals minus x plus 3. It's much easier on the eye because you can simply identify this with the gradient and the y-intercept. So straight away, quick sketch method, we can plot it from this format over here. The y-intercept is +3 and the gradient is -1. This minus means there's an imaginary 1 there. We can put that if you want to. So once you can do that, it's pretty easy. So the y-intercept is 3. Every one you go across, we go down 1. Every one you go across, you go down 1. 3 dots, we draw a line, and that's how we do this one. So we've rearranged it in this format over here. We'll draw the line. There we go. And that's your equation for this. So x plus y equals 3 is this equation over here. The same thing, but we've rearranged it to make it look like y equals -x plus 3, like in that form, because you can only plot things in y equals mx plus c. Section C on your revision card. Let's pause this slide. Let's write down how you'd write down any equation with x plus y equals c. So you'd simply rearrange this. We've done this just now. Make sure you understand this. Once it's in the form of y equals mx plus c, you can simply do this quick sketch method. Hence, always rearrange it to make it look like that form. Pause this video slide. Cool 1. Press pause. Write this question down, parts A, B, and C. Press play when you're ready. So this question is all about applying y equals mx plus c to a context, and in particular looking at two different variables to represent x and y. So the graph shows the volume of liquid, okay, in a container at time t. So we have an x and a y axis. This should be given to you already. We can call this over here L, number of liters, and this is t, the time in minutes. 1, 2, 3, 4 minutes, etc. minutes on the x-axis. So find the gradient. Now to find the gradient, we need to pick 2 points from this, 2 clear points on this over here. We're going to pick, let's say, this point, 0,4, and another clear point that goes through, let's say, 2 clear whole numbers. Let's pick this point here, 8,0. 2 points, we always do this. Points means coordinates, by the way. Now you should know the gradient means change in y over change in x. We defined that before, is change in y over change in x. We could get more detailed into this and write the actual formula as this. y2 take away y1. And we'll explain in a second what this actually means, okay? Over x2 take away x1. It means a change in y, which is your numerator, over the change in x, which is your denominator. So let's define these 2 points. It doesn't matter which one is A or B. We'll call this one A over here. Let's write this as such over here. So A is defined as 0,4 and B is defined as 8,0. So let's say if you were to understand this visually, you would actually do this. You would say, how do we get from here to here? We would go this much across, which is going to be 8 across, and you would simply go down this much over here, which is going to be 4 down. Okay, so visually you can see this over here. This is going to link into what we're doing. We're going 8 across and -4 down. Okay, now this is more a detailed version. Let's call this x1 over here and y1. Okay, and x2, y2. It matters that he called them the same number, i.e. 1, 1, 2, 2. Okay, it doesn't make a difference which one is which. Obviously, if you were to do this originally, in this case, this is definitely going to be x1, y1 over here. So let's plug this into here. So this equals y2 take away y1. So y2 is going to be 0 take away 4 all over x2, which is going to be 8 take away 0. 0 take away 4 is -4 all over 8. This is going to be simply -1/2 if we break it down. So that is our gradient, -1/2. Okay, so make sure you understand this formula over here. It's very, very important. Now let's go to part B. What does this mean, the gradient? What does the gradient actually mean? It means basically well, in the simplest terms, it's a steepness between 2 points, okay? But what does it mean within this example over here? Now, it means every one you go across, we go down a half. Okay, so one across, down a half, one across, down a half. One across in this context means every minute. So we always start with the x-axis being minutes in this question over here. Every minute that passes by, this is going down a half. Okay, so it means that every minute that passes by, the number of liters goes down by half. So the container is losing, let's say, 0.5 liters. It's like a bathtub. Take out the bathtub, the actual plug, you're losing half a liter every minute. Same concept. Part C, explain what the y-intercept represents. So in this concept, the y-intercept over here represents 0,4. So 4 simply represents what we started off at the beginning. In this container or bathtub, it had 4 liters to begin with. Okay, so that's what it means in a nutshell over here. 4 liters. That was the starting point. Okay, when full. Obviously, you can elaborate on these parts B and C, but these are the key concepts, how to link it to the actual question over here. Question 2, core 2. Press pause, write parts A and B down. Press play when you have finished. So this question, core 2, is going a bit more in depth in terms of the detail of mx+c, but still should be quite a good question to look at. So we're going to cover the points of midpoints over here and rearranging the gradient. Point A is the point with coordinates 5, 6. Point M is the point with coordinates 11, -2. So M is the midpoint of the straight line AC. Find the coordinates of C. So let's try to understand this from a visual point. First of all, A. We don't need to do an axis over here. Let's just say A is 5, 6 over here. Okay, and B is 11 -2. So 11 across, roughly to the right a bit, and -2 over here. This is going to be M. Okay, the midpoint. So we want to find out C. C is going to be a point which is a bit longer over here. So if you visualize this, we really want to find out this point over here, from here to here, to maybe over here. Okay, so this has helped us visualize this straight away. What is this point over here? That's the question. That's C. Okay, you don't have to draw this, but any mx+c question, I'd recommend doing it like this. This is what you need to find out. So first of all, let's look at these two, A to M, because we know the gradient of A to M will be the same gradient as M to C. Okay, so how do we get from here to here? So again, we're going to look at this. Let's do it in this format over here. How do we get from A to M over here? And how do we go down as well over there? So how many are we going across? Now listen carefully to this. So from the x coordinate, we're going to go from 5 to 11. We're getting 6 across, and from 6 to -2 is the y. We're going -8 down. If we use our formula, or if we look at this, in fact, the change in y over change in x would be -8 over 6, okay, which is -3 over 4. That is our gradient. Now, how do we apply this to this over here? The same thing has to apply. So we have to go 6 across. So we go 6 across over here, and we go -8. This is not scale, by the way. We have to go 6 across over here, and let's close that, and -8 down. So 6 to the right of 11, this would give us an answer of 17, and -8 down from here would give us -10. That would be the coordinate, 17 - 10. A quite challenging question, but definitely within your grips. By the way we got this -3 over 4, you could have done the more formal way, y2 - y1 over x2 - x1 from these two coordinates. I did it a bit quicker like that. So that's your answer, 17, -10. Take note of that. Part B, let's look at this. Point A has coordinates 3, 8, and point B has -1, 6. The gradient of line AB is -2. So A and B, this time they're giving you the full thing, okay? And they're saying that the gradient between these 2 points is -2. Now, We don't know what A is, but what we do know from gradient is that we have 2 points, and we have basically y2 take away y1 all over x2 take away x1. That will definitely give us this gradient over here of -2. It doesn't matter which ones we plug in. Let's call this one over here x1 comma y1, and this x2 comma y2 over here. Okay, let's just rearrange this now. So y2 is defined as 6 minus y1. Y1 is a, in this case, a or x. It's the unknown, doesn't make a difference. Let's put this all over x2 take away x1. So x2 in this case is -1, and x1 is 3. So this whole thing equals -2. Let's go a bit over here, save some space. So we're now going to go and see how we can rearrange this. So x minus a all over -4. We see, because -1 minus 3 is -4 equals -2. We can now cross multiply this to say 6 minus a equals -4 times -2, because it's cross multiplication, it's 8. We can now do basic rearranging the equation for this. If we take this 8 to the other side and this 8 to make a -8, 6 minus 8 gives us a. Therefore a is equal to -2. So it's a bit tricky, that one, but still look through it. It's something you could still do. A is -2, one of the more challenging questions on the grade 5 questions. So a equals -2. Question 3, core 3. Press pause, write this question down, try to find the equation, and press play when you are ready. So in this case, we're looking for an equation in terms of y equals mx plus c, and this equation passes through these 2 points over here, a and b. So a is respectively 1 comma -3, b is 3 comma -2. So we want to find out the 2 parameters, in particular m and c over here. Okay, these 2 constants, m and c. Guess what? Let's find m first. M is your gradient. We know that from before, one of the questions beforehand. M is defined as y2 minus y1 all over x2 minus x1. Let's call a over here x1 comma y1, and b, let's call this x2 comma y2. Let's now fill in the gap. y2 is -2. Y1 is -3, so -3. Look how we've got 2 minuses over here to make obviously a plus. This whole thing now is going to be over x2 take away x1. So x2 is 3 and x1 is 1. -2 minus -3 is the same thing as -2 plus 3, so it's going to be 1, and this whole thing is over 2. Half is the answer over here, so half represents our gradient for this first part m. Now that's the easy bit. Let's find out the y-intercept. We always do the y-intercept first, which is obviously c in this case. So to do this, we're going to sub in one of the coordinates into our equation. Sub in, let's say, one of these coordinates into y equals a half x plus c. Look how we put half there because of the half from m here. Let's plug in, let's say, coordinate a, only because it looks slightly easier with a smaller number, but it doesn't really make a difference. Either one would do, but it doesn't really make a difference in this case. They're both very similar. So y in this case is -3, so -3 equals a half times 1 plus c. -3 equals, well, half times 1 is a half plus c. So therefore, if we do -3 minus a half, which equals c, the answer would be -3.5, or -7/2 minus 3.5 is what we'd write over here. So if I just do this over here and highlight this, we're very, very close to finishing this off now. So the answer would finally be y equals a half x minus 3.5. Note we could also write it like this if you wanted to. You don't have to. Y equals a half x minus 7 over 2, which would therefore equal x minus 7 over 2. You don't have to do it that way, but either way would be good in this case over here. So let's highlight. This is the main way we want to show this in this case. Question 4, challenge. Write this question down. Try to find out which line is parallel to this equation. Press play when you're ready. So this question, we're dealing with the word parallel, and more specifically, which linear equation below is parallel to y equals a half x minus 3. Now parallel, as you know, means the same gradient. So we in particular want to look at this half over here and see in effect what equation has a half as its gradient. We may have to rearrange a few to do this. Let's have a look. So over here, y equals minus a half plus x plus a half. Clearly this is going to be minus a half here, so this is not going to be the one over here. We want a half. 2y equals 1 minus x. Let's rearrange this. So y equals 1 minus x all over 2. This is the same thing as saying y equals a half minus a half x. Okay, and here we can rewrite this again as showing y equals minus a half x plus a half. We also like to write the x first, mx plus c. This is minus a half, it won't work. Next one, let's rearrange this one over here. So we've got minus 4y equals, let's say, minus 2x plus 6. We've created this plus 2x over here and shifted it to make a minus 2x. This now, let's divide everything by minus 4. So y would equal minus 2x plus 6 over minus 4 over minus 4, which actually is going to be y equals a half x plus, let's say, 3 over 2. This actually is a minus over here. This works because we have a half over here. Half matches a half over there. 2y equals 4x plus 3. This would be y equals 4x over 2 plus 3 over 2, which actually equals y equals 2x plus 3 over 2. So in fact, what we have is this one. This is the one that works. The rest are just obviously there to confuse you, but you've got to rearrange each one if you have to get the right answer. So part C is the answer over here. Section D on your revision card. So we've now learned how to use parallel lines. So make sure you understand parallel lines are both two equations that share the same gradient or the same m. So pause this slide, write that down, and this word comes up a lot in basic mx plus c. This is the maths revision card, how you should look like at the end of this video over here. So let's go through each one of these. So you should have understood how to have calculated the gradient given 2 points. There's a special formula for that, which is on your toolkit A. Calculate the midpoint. Again, there's a specific formula for that, for the midpoint. How to rearrange a given equation to make it look like y equals mx plus c in this format over here in order to plot it and to find the gradient y-intercept. And parallel lines, you should know a bit about that as well. How two lines that share the same gradient have the same parallel lines. So these are the 3 clear steps you should have learned through each question. We mainly go through these things: how to identify, how to plot y equals mx plus c given the quick sketch method. Okay, we'll look at the y-intercept first and then the gradient. How to calculate the gradient given 2 points. We've touched about that a lot in this video over here. And sometimes they ask you how to calculate the full equation y equals mx plus c. You need to find the value of c, substitute values of x and y in order to find c. So pause this, make sure you've written this and understood this, and let's turn over for a quick refresh of our toolkit sections. Here are all your 4 sections on basic mx plus c. So you should have written this down on your revision card. So make sure you have it looking like this so we can tackle these let's do it questions. So sections A, B, C, and D. Pause this slide please and look back at these. Question 1, let's do it. Press pause, write this question down, find the line L2 parallel to L1. Press play when you're ready. Question 2, let's do it. Write part A and B down. Try to solve this question and press play when you are ready. Congratulations, you now have finished the basic level of y equals mx plus c. So go back to your notes, go back to your revision cards and these questions, and make sure you have the highlighted toolkit in front of you, so it is all good for your exam. Go back to your revision planner, make sure you're on a feel good factor, tick it off on your barometer, and well done.